Welcome to LeetCode Solver, and I'm a LeetCode Solver. Today we are going to solve a 15th problem in 30-day LeetCoding challenge. And I'm going to open the problem for the first time, and we are going to solve the problem together. So basically, I will try to solve the problem in the manner that we actually have to solve in real coding problems in interviews. So let me open the problem. Problem name is product of array except self. Well, let me read the problem. Product of array except self. Given an array nums of n integers where n is greater than 1. Okay. Return an array output such that output I is equal to the product of all the elements of the nums except num I. Well, okay. For example, 1, 2, 3, 4, then output will be 24, because if we do the product of all the elements, 2 into 3, 6 into 4, which is 24. Yeah, the for every index, the output of I will be equal to product of all the elements except num I. So as what I understand by reading the problem is like we will be given the input array, and for every index, output of I will be equals to product of every elements except I. So this is 2 into 4 into 2 into 3 into 4, and output of this index will be 1 into 3 into 4, and this will be 1 into 2 into 4. We are ignoring 3, and here we have to ignore 4. So 1 into 2 into 3. So this is what I understand by reading the problem. So definitely output should be 24, and this is 12, and this is 8, and this is 6. Yes, this is the expected output. Now constraint. Let me read the constraint. It's guaranteed that the product of all the elements of any prefix or suffix of the array. Prefix is the array starting from the 0 index till the ith position is prefix, and suffix is starting from last position till the ith position. This is suffix starting from the last position. So what does it say? It's guaranteed that product of the element starting from the prefix or suffix of the array, including the whole array, fits in 32-bit integer. Well, that's nice, actually nice um, explanation of the constant. So if we multiply everything, then we can still be able to hold it into a integer data type. Now please solve it without division and big O of n. This is not okay. And follow up is, could you solve it without constant space complexity? Oh, okay, with constant space complexity, I mean the output array does not count as extra space for the purpose of space complexity analysis. Okay, so we can still define output array. We can define output array, and we have to solve it. Okay, now what does it say? Without division. So the brute force approach, or the easy approach that came into my mind is, if we multiply whole things together, which will fit into 32-bit integer, and in each step if we divide it by that element, then the value we get will be output of that index. But according to problem, we cannot use division, so please solve it without division. So if we, and big O of n, so if we do this, then it is a very obvious solution. Like uh, if we have multiplied it like 1 into 2 into 3 into 4, then in every step here, if we divide it by 1, then 1 will be removed, and remaining case is 2 into 3 into 4, which is be there. And in second step, if we have multiplication of this, and if we want to ignore 2, then we can simply divide it by 2. So if we divide it by 2, then 2 will be there. If we divide it 2, then result will be this 1 into 3 into 4. Then similarly, in the third case, if we divide it by 3, then we'll get this. So similarly, we can generate output array. But according to problem, we cannot do any division. Well. Then big O of n complexity. Okay. If we can't do division, then what we can do? Okay. So what I'm thinking is, if we cannot do division, but still, if we instead of storing whole variable as a deep variable, like as a product variable, like product of all, which is equal to 1 into 2 into 3 into 4, is we have to find the product of all elements which is in the left side and product of all elements which is in the right side. Then, like, if I want to find the product at 1th position, this position, then the answer will be multiplication of all the product to the left side, which is 1, multiplied by product of all elements to the right side. So basically, it's we can apply the concept of prefix multiplication, and if we multiply it, prefix multiplication, before, which is before I, multiplied with suffix multiplication after I. So if we have this, then we can get multiplication at I. We can get multiplication at I by doing this kind of multiplication things. Okay. Then if we somehow calculated all this calculation by iterating over the array, if we store all the values in a prefix multiplication, like as going from left to right, I put all those multiplication in a prefix multiplication array. Suppose I have a array prefix multiplication. Then while iterating, I will do multiplication things as well. The first multiplication is 1, and second multiplication is previous multiplication multiplied by 2, which is 1 into 2, which is equals to 2, and third multiplication is previous multiplication multiplied by 3, 2 into 3, which is equal to 6, and fourth multiplication is previous multiplication multiplied by 4, multiplied by value at that position, which is equal to 24. So overall array will be this. So we have prefix multiplication table, and similarly, if we have suffix multiplication table, then we can easily get multiplication at position I, which is the required output according to problem statement. Output of I will be equal to prefix of prefix mult up to I minus 1th position multiplied by suffix mult after starting after I. So this is the required answer. Now what if the array size is, what if the position is 1 for the prefix mult? If position is 1, we can simply multiply it, assume that there is 1 as a prefix mult, so that we can apply multiplication with the suffix mult. We have to consider the corner cases, like what will be the prefix mult for this position and what will be the suffix mult for this position. I mean, to be applied for that position. So let's calculate suffix mult here as well. So suffix mult of this position is 4, and suffix mult of this position will be 3 multiplied with 4, which is equals to 12, and at this position will be 12 multiplied with 2, which is equals to 24, and finally this position same as 24, which is 24 multiplied by 1, which is same as 24. Well, this is our suffix mult array, and now we can easily utilize this multiplication in order to find that output array. Well, now the corner cases, if there is only one element, if there is no element, we can simply return empty vector if the vector is empty. But if vector is 1, then what will be the multiplication? If the size is only 1, then multiplication except self, according to problem. Product of array except self. So if we ignore self, then product of everything is 0. But given the array where n is greater than 1. Okay, awesome. Nice. In that case, we do not need to consider this because we will always have something like this. If we have something like this, then also we do not need to consider this case as well. So if we have something like this, then we will always can calculate the answer, because like for this case, the multiplication will be 2, and for this position, multiplication will be except self, so 1. Yeah, all right. And now so similarly we can apply this fact that prefix mult of this position can be 1 and suffix mult of this position can be 1, so that we can the multiply with the other remaining counterpart, either suffix or prefix mult, and the multiplication with 1 will be that value. Okay, nice. Now we have another constant that constant, we can't use any extra space, we can just utilize output array, so we can use only one array as a space. So is what I was seeing while generating this prefix mult and suffix mult is like, if we generate one, then that would be sufficient in order to calculate the answer. This is how is this sufficient? Because if we have this one, then while generating this one, we can, in order to generate this one, we have to iterate from the right side towards the left. And while generating this value from the right side, like if I want to generate this, then I have to take consideration of 4. And if I have to take consideration of 4, then then what I can do is the answer will be multiplication of prefix mult, which is up to this 6, and multiplied by suffix mult, which is already calculated. So in this case, we can, the value which is outside of this position is 1. So as we mentioned as a I mean corner case. So we can simply multiply 6 with 1, and we will get that value. Now as a 6. Now if we move to this position, then we have to know that we already calculated this as a what this is 4, this is 4, and then after 3 into 4, which is 12. So at this position we calculated 12 as a suffix multiplication, and we already have this, and we already have the value at this position, which is 4, and before calculating this position we had this one. So at the current position we already had this one, and we already have this one, which is 2, and we already have this one, which is 4. So if we multiply 4 with the 2, then we will get 8 as a current answer, and then after we can multiply that 4 with the 3 to get the 12, and when we get the 12, then we can go to the next step, and we can multiply with the 1 in order to calculate the value at this position, and we will get 12 into 1 equals 12 as an answer. So if we have somehow calculated prefix mult at the first time, then we don't need to keep track of these things in an array, because while doing the calculation we can easily generate our answer as well. Now after generating answer, we can also see that if we generate the answer, then we can simply erase these already calculated value, because we already calculated this value like 6 the answer at this position as a 6, and uh, at that time we no more need to know the value at this position of prefix mult, because if we are at I position, then we always need a prefix multiplication which is before of I. So we can simply replace the value at current position I position with that output value. So we can use the same array in order to store this multiplication value as well. So we can now achieve only one big O of n space actually, using only one output array. So we can utilize only one output array in order to calculate, in order to store the uh, output of our result. So let's go for the implementation. Let's define n as a size of the array, and let's define a prefix. Prefix is also can be used as a output according to problem. So let's use output as the array name, and which can be, which is of size n, and all the elements can be 0 initially. And we can use the same array to calculate the prefix sum. So output of I will be equals to, if I equals 0, then the output of I will be nums of I. Otherwise output of I will be same as output of I minus 1 multiplied by current value. So in this way we calculate prefix multiplication at ith position. Well, we calculated this one. Now while calculating the suffix multiplication, we can actually replace the output array values. So output of I will be something. What is that something? Which is, let's calculate suffix multiplication. 1, and it will be same as suffix multiplication multiplied by, let's better to let's write in the same way as we defined previous formula. So we can easily say prefix of I minus 1 multiplied by suffix mult, our previous suffix mult. Now we have to update suffix multiplication. Suffix mult now will be equals to, will be multiplied with current value, which is nums of I. So we updated our suffix mult. Now let's there is a corner case, like at 0th position I minus 1 will be equal to 0, minus 1. So in this case we do not have any, we have to multiply it by 1 as we mentioned before. So say, let's write down if else condition over here, ternary operator. So if I is greater than 0, then this else multiplied by 1. So we will get a value over here. Whatever value we are getting over here will be multiplied to suffix multiplication. So basically we are implying this formula, prefix multiplication before I. So if I is greater than 0, then it will be simply prefix of I minus 1. Otherwise we will multiply it with 1, and we multiply it with suffix multiplication after I. Well, now we can simply return our output. Okay, so the time and space complexity, let's analyze time and space complexity, because we are iterating over the array only for the 2 times, so it is big O of n, and space complexity is big O of n actually, but according to problem, if we use output array which doesn't count as an extra space for this purpose, uh, so we can say that according to problem we can take it as a constant space complexity. Well, now let's test the problem with uh, the given test case. Let's analyze 1 2 3 4 what happens. So first of all we calculate the size of the array, which is 4, and we define the output array, and we populate the value in the output array, which is which is basically prefix multiplication. We populate the prefix multiplication. If value at I position, if I is 0, then we are simply putting nums of I, that means current value, multiplication with current value. So here it is, output is 1, and for the given array, so array is this, nums is this, so this is 1, so far output is so far 1. And next step, the I is greater than 0, so it will be output of I minus 1, our previous output, which is 1, multiplied by current value, so 1 into 2, which is actually 2. And in the next step, this is same as previous output multiplied by the current value, so 2 into 3, which is equal to 6. And in the next step, the value will be previous output, which is 6 multiplied with current value, which is equal to 24. So we overall we generated the prefix multiplication array. Now we are going to do the same from the back side, from the suffix side. So initially suffix multiplication is 1. So basically which tells us that uh, say let's we already define over here. So which tells us that there is the suffix multiplication of the values which is at the last side. X there is something, so this is 1. This is suffix multi. Let's define suffix. If it is suffix mult array, then the condition is something like this. Now in the next steps, if I is greater than 0, okay, this is for basically for multiplication. We are also calculating the output of the uh, our answer. So our answer will be generated by multiplying prefix of I minus 1, the uh, multiplication of all the values which are before of I, so prefix of I minus 1, and we are putting this ternary condition because if we are at 0 position, then we have to multiply the previous prefix multiplication will be taken as 1, so that it will have no effect if we multiply with all the suffix multiplication value. So right now we have we satisfy this condition. So at position n minus 1, so we are at this position and we are satisfying the condition of taking prefix I minus 1. Prefix of I minus 1 is 6, so we are multiplying 6 with 1. Suffix of multi is 1 right now, so we take this value as our suffix multi our output answer. So the output answer 24, this will be now replaced with 6 because we no more need the prefix of this position, because we are always calculating and taking consideration of prefix of I minus 1 position. So the okay prefix, so this is basically output. Prefix is stored in output. So we are we always need output of I minus 1 position to multiply with suffix multiplication. So we can simply replace the current output of I. Current output at ith position can be replaced because we will no more need in other steps as we iterate from the right to left. Now this is 6, 6 and 1. Now we update the suffix multiplication, which is previous is 1. We will multiply with the current value, which is 4. So now suffix mult will be equal to 4. Now in the next steps, we are at this position. We are at this position here. So now output of I minus 1 will be equal to this one, and we will we have 2 into, so output of this position is 2, and we have 2 into suffix mult. Previous suffix mult was 4, so we multiplied with this. So now we will get output as 8, and we replace that value at this position. So now we have 8. Now in the next steps, we are at this position. At this position, we have prefix of I minus 1, which is prefix multiplication is 1, and we will multiply 1 with our previous suffix, which we updated here with suffix mult, which was 4, and we updated it with suffix mult was 4, and we updated it with 4 into 3, and it was 12 before. Now it will be 1 into 12, which will be equal to 12. Okay, and we will replace this position, so it becomes now as a 12. Now when we move to this position, now the position is this condition do not satisfy, so it will go take 1 into consideration, and 1 will be multiply with the value which we updated before. So the value we updated before was 12 into the value we updated before was 12 into the value at this position, so 12 into 2, which was 24. So it was 24. So we will replace this with 24, and now we will get 24. Well, in this way we populate every value, and now we'll return output as answer. Let's test with our other custom test cases. uh, what happens if we do not have any case for 1 values and 0 values, so we have to have at least 2 value. So let's run with this. The output will be 5 1. Okay, as expected. And if we run with 2, and can 0 be there? Okay, 0 can also be there. And what happened in this case? 0 and 2. Yeah, if everything is 0, everything will be 0. Well, alright. Okay, let's submit the problem. Accepted. Let's go into details. 36 ms, 10.4 megabyte. Okay, alright. I explained my thought process as well as I shared my implementation from the very beginning, and I also explained the time and space complexity. Did I write the time and space complexity? Let me write down again. So time complexity here is big O of n, or n is size of given array, and space complexity is also same because we are using extra space for output array. So if we, according to problem statement, if we consider this as a, we can consider this as a constant space. So no surprise. Yes, that's all. Okay, thank you everyone for watching this video, and please feel free to comment and present your thoughts and ideas, as well as your thinking process, as well as your approach for this problem. If you have any different approach or different solution in your mind, please feel free to share. And yeah, please subscribe this channel if you think that it will be beneficial for you. And if you are preparing for the coding interviews, as well as if you are willing to learn the algorithms and data structures, and go through the thinking process, or analyzing the problems that may be beneficial for your for solving the problem, or if you are stuck in some problem and you want to get help from from these videos, then please feel free to like and subscribe to this channel. Thank you everyone, and have a nice day.